Okay, if we have an f of x and a g of x function as depicted here, just based on the graph without having to worry about a table, and we use the table to connect what we were doing before to the functions that we were graphing. And these tables have nothing to do with these functions. Well, here's what we can do. For any point at which both functions are defined, for any value of x for which they're both defined, we can draw a vertical line through both. Okay? The values of f of x are going to be depicted by the yellow arrows. And we can do this at as many points as we wish. And eventually, after we've done a few, we get a little more picky about the way we choose our points. But these arrows represent the values of f of x. These are the y values. These are the y coordinates of these points on the f of x graph, and they correspond to these values of x, right? Well, we do the same thing for the g of x values. And we couldn't do this with the graph that we had before just because of the asymptotes and the nature of the graph. Just a little tiny arrow there. But we can imagine doing it for that graph. Here we can actually go ahead and draw it and construct it. Okay? So now we've got our g of x arrows. So if h of x equals f of x plus g of x, well, we just take one of these arrows and put it on top of the other, right? And let's be consistent. Which arrow do you want to put on top of the arrow? Do you want to put the yellow arrow on top of the purple arrow, or the purple arrow on top of the yellow arrow? Just pick a color, and that's one.
On top of purple.
Huh?
Yellow on top of purple.
Yellow on top of purple. So here's yellow. We're going to put that on top of the purple because we're adding these two values, right? I do think in elementary schools people ought to be working more with arrows and number lines so they would understand stuff like this. Okay? Because it's easy to do. You just learn to draw the arrows. Teach a 7-year-old to do that. Might not be the best time to do that because not sure just at what age they would process it most appropriately. Anyhow, here we have this. Okay, now we'll put the yellow arrow on top of the purple arrow. And the yellow arrow is this long, so we're going to have to come all the way up here. And that's going to give us an h of x arrow that's this long, right? So we can already see our h of x functions kind of doing this. Now let's see where it goes from there. Well, now we're going to have to put the yellow arrow on top of a purple arrow that goes downward, right? So, we've got to be a little careful how we do that. We're going to go from here, so it means we're going to come up to a point that's not quite as high as what we were before. Right? And that's a little subtle and hard to see unless you explain it, but it goes from here up to here instead of from here up to here, same length. Okay, so now we have an h of x arrow that looks like this. And then we just continue doing the same thing. Putting this arrow on top of this one gives us an arrow. Comes up to here. So here's our h of x. And of course, all these arrows really need to be on the same vertical line, but if I put them in the same vertical line, you're not going to be able to see them, so I'm offsetting them just slightly. But you have to understand where the points would really be. Okay? And then look here. Here's a yellow arrow that's not quite as long as the purple arrow, but this means that somewhere in this neighborhood there's going to be a point where the yellow arrow and the purple arrow would be the same length but opposite, right? Well, that's the kind of thing we actually look for when we first look at a function. We're not doing that now because we're drawing arrows, but okay, so we bring the yellow arrow down here It's going to be this. And of course the h of x arrow starts at x equals 0, because this is going to be the value of the h of x function, right? It'll be negative, okay? Well, then we come to here, and it looks like we've got another place that is pretty much equal and opposite. So I just drew those lines. I wasn't really looking. I just lucked out and got one that's pretty close to equal and opposite. So if I bring this arrow down to here, it looks like I have a point where h of x is 0. That's something we always look for, okay? So I can't draw an arrow, but I'll draw the point. Okay, then the same thing here, but now this arrow goes on top of this one. I get this picture, and now here's my h of x. And that means that if I put these points corresponding to the values of h of x on the vertical line, that I started with, here are my h of x values, and now I can just follow the trend of my points. And here's my graph of h of x equal to f of x plus g of x. Okay? Now if I want to do h of x minus g of x, well, I'd reflect g of x through the x-axis. All the values would become the negatives of what they are, and I'd add them. Okay? If I want to do f of x times g of x, well, I haven't asked you to do that at this point, and we'll get to that later in the course, because that's a little more complicated, a little harder to look at.
Yep.
But again, point now is we can represent the values of the functions for any value of x by arrows, and we can combine the arrows to get the sum of the two graphs, right? If I want to do f of x minus g of x, instead of reflecting the g of x graph, I could just reverse all the g of x arrows and add them to the f of x arrows. Okay? So there's a lot we can do. It's important when you're looking, many times in science, in management, in business, in economics, you have two functions. For example, if you've got a revenue function and a cost function, okay? You got to subtract the cost from the revenue to get your profit. Well, if you've got two graphs, how are you going to visualize the graph of your profit? Okay? You're going to have to see, by looking at the graphs, how to subtract them. Otherwise, you're going to have to go to somebody that knows what they're doing and get them to create the graph for you and look like a fool. Okay? If you're in a position where you're supposed to know that. Okay? But if you know that, and it's not that hard with a little practice, then you have an advantage over most people who can't visualize that. Also, it gives you a thinking tool. You know, you're trying to visualize what might happen. You don't have to go to a graphing calculator. You don't have to go to a computer program. You know, you say, okay, if the profit does this and the cost does this, because they kind of go this way, what's going to happen? Okay? Just one example, and in the sciences there are numerous examples, but I'll use a business example because we got more business people than we got science people right now. Okay?